In this video, we're going to be covering this practice quiz on solubility. So we're going to go over the like dissolves like rule. So you have to tell if the solvent is polar and if the solute is polar or ionic. So you have to be able to tell if it's ionic or covalent. So H2O, it's a small molecule with the central atom. So when you draw it out, it's going to look like this. So hopefully you know by now that water is going to be polar. You have a negative. These are positives, the H's. On this one, the calcium, so just be aware of especially column 1 and column 2 and possibly the transition metals. But this is on the left of the staircase, a metal. This is on the right, it's a non-metal. So this is ionic. Okay, so water is definitely polar. And this calcium chloride is ionic. So it could either be polar, nonpolar, or ionic. And ionic is like better than being polar. It's a full-blown charge. You can have a 2 plus and a 1 minus on the two ions. So this is ionic. So this will definitely want to stick to the calcium, and then the H's on water are gonna go and surround the Cl minus. That's in a question down below that we'll get to in a second. So the polar and ionic, that's a definite match because you're going to have these opposite charges attracted to each other. So that's the like dissolves like concept, and it's going to be soluble. All right, let's look at the next one, butane. All it is C's and H's, so it's all C's and H's, and that's going to be nonpolar. So you want to be looking for O's and N's on large molecules like that. Methanol, there's one central atom that's going to be the carbon. So let me sketch this out real quick. I'll just draw it right here. So these three H's and then this OH are going to be the groups that are attached to this carbon. So there's going to be an H here, and then there's an OH here. And there's an oxygen on it. And this is going to, in fact, make dipoles here and here around the oxygen. The rest of this area is mostly nonpolar. Okay, but since it has this oxygen right here, it's definitely polar. So you have something nonpolar and something polar. This is not going to be soluble. It's insoluble. So there are no spots on here with partial negatives or positives for this to be attracted to. All right, let's move on. All right, so let's look at this one. So we have this piece right here is polar. We have some non-polar part of the molecule, but so for that you have to count the number of carbons. So if it's 8 or more, it'll be more non-polar than it is polar if this segment right here is 8 carbons in a row or more. So we see there's one here, 2, 3, 4, 5, 6. Yes, it's getting close, but it should still be polar. So this molecule, hexanoic acid, is polar. The hex, by the way, means 6 carbons. And then isopropyl alcohol. So here we have more than one central atom. We have these 3 central atoms. So the way you do this is you look for O's and N's. There's an oxygen right here. This is going to pull electrons towards it and be partially negative. So this is going to be polar. So this is soluble. All right, so now we have water. And this is polar. You could rewind and look at the explanation for part A. It's polar. Isopropyl alcohol, that's the same solute as this one. This is polar. Isopropyl alcohol is rubbing alcohol, by the way. And this stuff, if you buy it, you can find it at like 70%, or I think you could find like 90%. I think you could even find like 60% or something. That means it's 70% isopropyl alcohol. The other 30% would be water, and you don't visibly see 2 parts. It's fully mixed together. So this is polar and polar. It's going to be soluble. All right, so on to the next question here. So let's go to number 2. So it says, show how water hydrates calcium chloride. Example A in the table above. So I mentioned this a minute ago. So here's our cation. Here is our anion. And it says to use 2 solvent molecules for each solute particle. So if you watch the old lesson on this, is the lesson on solubility. You'll see these drawn. There's a lot of questions, a lot of review on this. So here's water again. So, and we know that this is slightly negative, the O, and then the H's are slightly positive. So the water molecule will, the O will face towards the cation. The H's are going to face towards the anion. So it says just use 2 solvent molecules. So that means to draw water twice. Draw water 2 times. And you kind of have to like turn it around in your head. So you have to imagine water. So here's O. Okay, and then I drew another O. H. So it's going to face it like that. Let's draw another one. Let's draw it over here like this. So face it like that. So the negatives face the positive cation. And then on the anion, we're going to turn water around and draw it like this, so that the positive H's face the negative anion. Let's draw another one over here. Okay, so that's two solvent molecules per solute. Okay, so that's each solute particle. The calcium and the chloride, it splits up into those 2 charges. All right, so how does water dissolve isopropyl alcohol? So let's draw, and it says use 2 solvent molecules for each solute particle. So isopropyl alcohol is not going to split up. So it's going to be, it's covalent. Covalent's not going to split into charged particles. So we're going to redraw isopropyl alcohol. I think I had the OH group on the other spot, but that's okay. Same thing. All right, so here's what's happening here is this is the primary area where it's polar. You have a partial negative, and this is partially positive on the oxygen. So what's going to happen is, let me see if I can make this a little bit smaller. Okay, that way I can fit my solute, or my solvent, I mean. Okay, and so here's water again. So let's scroll up a little. So here's water again, and we want the negative on water to be lined up with this positive. So what I'm going to do is I'm going to take this water molecule and turn it around. Okay, so I'm gonna draw water like this, like that, and then I'll draw another water. So let's do. So it says to add 2. So let me add another one. So I'm gonna do a water right here. Let's draw the H first. Let's draw an H right there, showing it's attracted to this oxygen. Okay, so there's an attractive force between these 2. I'll use these green dotted lines right here. And then I'm going to draw another water like this to show how the O would be attracted to this H right here, like that. Okay, and the rest of this molecule, this whole area right here, all this stuff is non-polar, so you shouldn't have any waters around that area. And then that's the general idea, is you want this positive to be facing the negative and this negative to be facing that positive. And that's more or less how it would dissolve. All right, so factors affecting solubility, that's what this question's about. So it says raising the temperature of a liquid solution when the solute is a gas. So let's say you had a beaker and then you have a liquid. So the liquid is the solvent. So you have a liquid solvent and you have a gas solute dissolved in it. If you heat it up, so let's add some fire. So you heat up the water or whatever liquid that is, and then the gas would escape more. So there would be a decrease in how much gas is solubilized in the liquid. So we're gonna write decrease. So increasing the pressure above a liquid solution when the solute is a gas, this would increase the amount of gas that's dissolved. So let's take our same picture. Let's get rid of that the heat there. So let's say you had a way to cap this, and then there's like a special valve here with a pump right here. Okay, and then you pump this, you pump it up and down, and then you add air onto the top. Meanwhile, it's like sealed right here, so that's gonna keep these more dissolved. They'll stay in there. They have nowhere. They're like these purple ones I just drew are like pushing these black ones in. So that's going to increase the amount of gas that's dissolved in that liquid. Okay, so breaking the solid solute in half, that's what you're doing here is you're increasing the surface area and exposing more of it to the solvent. So that should increase the amount of solute that is dissolved. All right, that's the end of the practice quiz. Hope you did all right.